All right, and you can go back and put these answers. Of course, your numbers will be a little bit different. But the homework, like not getting 1 or 2 done in the homework and then doing it late, that won't even hurt you at all. I mean, it's designed, the system is designed so that won't hurt you at all. Because I know there was always for me when I took these math classes, like 2 or 3 or 4 that I just could not figure out till I came back the next day and asked the teacher. So it's designed that way. Don't worry about it all. Like if you didn't get it all the way done, go back and put these in. It won't even hurt you 1% at the end. If you do 2 or 3 every homework late, that won't even be 1% of your grade in the end. If you do the whole assignment late regularly, yeah, that's half credit. That'll add up. Am I making any sense? So don't worry about losing points. You won't even lose 1% of your grade. If you do like 2 or 3 after the fact every time, it's fine. It's designed for this kind of thing. This is how math classes are. They're hard. So, all right, so let's draw our triangles. So I'll draw a triangle over here, quadrant 2. So I'll put it over here, quadrant 2. And put my triangle. And here's angle A. And we're supposed to do SOHCAHTOA here, right? So tangent is opposite over adjacent. So opposite over adjacent. So this is opposite side, adjacent side. Hypotenuse. So tangent is 4/3, so this would be 4, 3, and it's negative. Which one of those is actually negative?
3.
Yeah, you can tell by its back 3, up 4, right? So it's actually back 3, up 4. But if you'd rather, you can just ignore all that and do it at the end. You know all that, right? What's the hypotenuse side going to be? Yeah, you recognize this one? Can we do this one without doing the Pythagorean theorem? 3, 4, 5, right? To be 3, 4, 5. Okay. So now, what do we need to find? I'm going to use the tangent formula. I'm just going to do I'm just going to do the third part here. So, well, maybe I'll find them all. Just in case, just to make sure. So you would need to do sine. There we go. It's not too big. So you need to find sine. Here, I'll just find them all real quick. So sine. What would sine be? Sine is, let me write it up here, SOHCAHTOA again. SOHCAHTOA, yeah. So sine is opposite over hypotenuse, yeah. So 4 over 5, right, opposite over hypotenuse. Cosine is adjacent over hypotenuse, minus 3 over 5. They've already given me tangent. That was, what they started me out with. So I have sine, cosine, and tangent for A there. Good so far. You can double check the signs. We're in quadrant 2. So it's supposed to be all students, take calculus. So sine and his upside down cosecant are supposed to be positive. And so the others are negative. So sure enough, sine is positive. The others are negative. Cosine and tangent. Good double check on the signs, right? It's all good. Okay, let's do the other side now. So on the other side, we are in quadrant 1. That's nice. Everything's positive in quadrant 1. Right here. So B is in quadrant 1. Cosine is adjacent. Let me do that here. Is adjacent over hypotenuse. So this is the adjacent. This is the opposite. This is the hypotenuse. So adjacent, 7 over hypotenuse, 8. So I'm going to have to find that other side by the Pythag. So A squared plus B squared is C squared. So that's 7 squared plus B squared is 8 squared. Like that. 49 plus B squared is 64. Subtract 49. B squared is, oh, it is, thanks, 15. So then root it. So this is root of 15. Can you read that down there? Root of 15. Good there for those 3 sides? Hey, there's also an old YouTube from like last summer or whatever, or this last summer. Yeah, so I don't know if anybody checked the other one. Maybe I covered on the other one. I don't know. You can always double. There's always a second lecture. I don't know if anybody looked there. Sometimes it's not there either. I just know it's right at the end. Yeah, that's right. That's always, I'm always saying, move on through, Brett. Move on through, because I don't get to the hard stuff at the end. I get bogged down the easy stuff. That's not helpful. All right. Anyway, so we got a root 15. You're like, I got that easy stuff. All right. So now let's come in here and let's find the other ones. Okay, so we got cosine right here. So we're going to get now, so we need sine of angle. So this is on the left side, we have sine, cosine, tangent for angle A. On the right side, we're getting sine, cosine, tangent for angle B, right? Everybody remember how these work? There's two different angles. So now angle B, sine, you know, is opposite over hypotenuse. So that would be root 15 over the hypotenuse 8. Cosine is already right there. So then tangent is opposite over adjacent, root 15 over 7. All right, now we have all the pieces for the puzzles. Got the sine, cosine, and tangent for A. Got the sine, cosine, and tangent for B. We can go do the stuff. Now, you guys was it just tangent that was a problem you were saying?
Yeah.
Just the tangent? Okay.
You gotta find the other stuff in order to figure out.
Do I have to do sine and cosine A and B first? I don't think I do I? Or, maybe that's not what you mentioned, no? So I just got to do tangent. What do they want? They want tangent of, they want tangent, of A plus B. I'm forgetting what we're even doing. That's right. Tangent of A plus B. So the formula for that, wasn't it tangent A plus tangent B over 1 minus tangent A times tangent B, like that? I remember, that's the one I'm always so about remembering, but I just did it Monday, so I think I've got it. Yeah, you can put it on your 3x5 card. That's why I give you guys 3x5 cards. I have no memory. Otherwise, I'd be a hypocrite here. All right, so now let's work that out. So, all right, so we can get each of those little pieces, but there's going to be some messy algebra at the end, like y'all are saying. So tangent A, what's that? Tangent of A, minus 4/3. So I'm going to go grab the pieces I need. Tangent of A is minus 4/3. So this part will be minus 4/3 plus tangent B. Tangent B is square root of 15 over 7 over 1 minus tangent A. What was tangent A again? The minus 4/3 times tangent B, square root of 15 over 7. Get that a little neater there. Okay, we good to there? We just got to work that all out now. Everybody good to there? So now we're going to multiply some stuff together. So, we're going to add. Yeah, this is a pain. Here, let me do this. Let me take it slowly. I'll bring it down to here. I'm just going to, here, line by line. So there's the first step. It's a big mess. So then I'm going to come down to here. Minus 4/3 plus root 15 over 7 all over 1. Double negative here. It's going to become plus. And I'm going to multiply these two. So that'd be 4 times root 15 over 3 times 7, 21. Let me halt there for a minute. Does everybody see what I've done so far? So I didn't do anything on the top. The top is, totally the same. The bottom, I just multiplied these two negatives, made positive right there, and 4 times root 15 and 3 times 7. I just multiplied, fractions. Top times top, bottom times bottom. So far, so good? Nothing too amazing yet. Now, this is what we call a complex fraction. It's a complex, fractions over fractions, a messy fraction. So the way to simplify it is, because I know you might have got common denominator up here and messed with all that. Actually, I'll give you a way better way. Just wipe out all those denominators. What's going to take? So take aim at all the denominators. 3, 7, 21. What number do they all go into? 21, huh? 21's a common denominator. Use 21 to multiply everything on the top, everything on the bottom. What I mean is 21 there, 21 there, 21 there, 21 there. That's okay to do, right? I'm doing the same thing top and bottom. That's how you handle complex fractions. You just multiply all the terms, top and bottom, by the common denominator. And what that'll do is that'll take out all the fractions. What do I mean, take them out? Well, everybody good so far? So this is what you always do with a complex fraction. Let me write a note up here. So with a complex fraction, which means fractions over fractions, multiply top and bottom by LCD. Okay, so then what happens? Well, these 21s are really over 1, aren't they? Any whole numbers over 1. So that means these cross cancel, don't they? 3 into 21, 7 times. Multiply what's left over. Minus 4 times 7, minus 28. Good for the first part. Do you see that? So 3 went into 21 7 times. And 4 times 7 is 28. So you cross cancel whatever's left over, you multiply. Right here. Can you do the next one?
It's going to be plus 3 root 15.
Very good. Is that next one making sense? These cancel. 3 plus 3 root 15. Good so far. Now how about the bottom? This is just 21 times 1, so no big deal there. And then right here, the 21s just totally cancel, so it's just 4 root 15. Now we're not done yet. I wish they would just let us answer that way. They won't let you type that in?
No, they're making
Get rid of the root? All of a sudden they're picky about that, huh? Okay. All right, we'll do one more step, which is not an easy step. But notice it's not a complex fraction anymore. It's just a normal fraction now. It's not fractions over fractions anymore. See how that always handles a complex fraction? You just multiply top and bottom by the LCD. That makes it a normal fraction. It's a little better. And now, Chanel, you good?
I'm good. I got the same answer you did, but I don't know.
Yeah, there's other ways.
Way
Did you get a
longer
common
than-
denominator here? And because you could do that. There's other ways.
No, I just took the cosine. I put the sine over cosine.
Oh, you did that. Yeah. And that'd probably be a little bit more work.
No.
It was okay.
Well, because you have to figure out the sine and the cosine anyway.
That's true. And then just divide
so,
them.
Yeah, you just put the sine
Good.
over the cosine.
So you got to here, and they
Yeah.
wouldn't take this, though.
No.
Right. Okay, so let me help you guys from there. So, and the problem is the root on the bottom. They don't like that root on the bottom. So let me bring it to a fresh screen. So minus 28 plus 3 root 15. Minus 28 plus 3 root 15. Yeah, you could do what Chanel was saying. I think I did that actually last summer when I taught it. I just said, well, just take the sine over the cosine. Sometimes that gets a little messy, but this time it's fine. 21 plus 4 root 15. Either way. Okay, so now we're to here, and they will not take that root on the bottom. Well, what do? Do you remember from algebra? What do you do about roots on the bottom?
Don't you have to multiply by the conjugate?
Good job. Good memory. Yeah, basically, here's the deal. I'll just briefly review. If you have something like 3 over 7 root 5, or 15, let's say. 3 over 7 root 15. In that case, you would only multiply by root 15. That's all you need. All right? I mean, just boom, done. But when you have pluses or minuses, right, I'm always saying this, it makes everything harder. Right? Pluses and minuses make everything harder. See, if you just had this situation, there's no plus or minus down here. They're not glued together. It doesn't matter. Just multiply top and bottom by the root 15. Right? That'd be super easy. Then what's root 15? Root 15, regular 15, it'd just be 7 times regular 15. I think it's 105 or something. You know, and then you're basically done. Or maybe 3 goes into that. I don't know, whatever. You're basically done. You got rid of the root. Simple if there's no plus or minus. Like always. Anytime you see plus or minuses, you just know you're in for trouble. I mean, it's always something the harder way. So anyway, so what do? When you have a plus or minus, let me write a note for you somewhere. So when a root and plus or minus in the denom. So when you have a root and a plus or minus, they're glued together, right? Like always, plus or minus Costco glue. So what do? You multiply top and bottom by what's called the conjugate. What does that mean? That means opposite sign in the middle. Same as the denominator, opposite sign in the middle. Opposite sign in the middle. So here, I'm not writing this very well. Let me try this again. What the conjugate is the same as the denom, but, so same as the denom, but opposite sign in the middle. Yeah, it's a whole special difficult thing. So you have to use, so when you have plus or minus and a square root in the denominator, you got to multiply top and bottom by the conjugate, which means exactly what you're seeing in the denominator, just exactly the denominator. So I'm gonna go times 21, but opposite sign in the middle, minus 4 root 15 over 21 minus 4 root 15. That's what you've got to multiply top and bottom by. That is actually what it takes to get rid of the root, is that whole special thing. You good? All right. Okay, now we distribute. Boom, boom. That's one of my favorite previous students. I recognize his as Chin Hao in the hall out there. He's a fun guy. All right, so let's multiply through all those terms. So 28 times 21. I don't know, some big numbers here. I'm using my calculator. 588. Oh, negative. Thank you, Chanel. So it's always helpful to have other people watch you while you do the math. That way you don't mess up. 4 times 28, what is that? 8, I don't know. Give me a number. 112. 112 root 15. See how the two negatives make, be real careful with your signs. I almost messed up already. Two negatives make positive there. I multiply negative 28 times negative 4 root 15. The two negatives make positive, and the 4 times 28 made the 112. Good so far? And then now this guy's going to go boom and boom. 3 times 21, what's that? 63 root 15 minus, and 3 times 4. Yeah, and you okay with this one? Remember, I know it's probably been a little while since you've done these root rules, all these fancy rules for roots. So I'm about to multiply 3 root 15 and 4 root 15. How does that work? Well, 3 times, you just do outside stuff with outside stuff, inside stuff with inside stuff. Outer, outer, inner, inner. 3 times 4 is 12. And what is root 15 times root 15? Plain 15. So it's going to come out whatever 12 times 15 is. I'll do that in a minute. What is it? 180? Thank you. That'll be 180. Everybody see what happened there? How the two root 15s made a plain 15 when they multiply? Right? The 3 times the 4 made 12, and the root 15 made plain 15. That's the denominator. I'm sorry, that's the numerator. Now for the denominator. You tracking? Okay, can I answer questions on that? That makes sense what I did up there? All right, you feel free to speak up. Let's go to the bottom now. 21 times 21, some big number, 441. Minus, and now it's 21 times 4 root 15. It's going to be negative, what's that, 84 root 15. Oops. And now he's done. And now it's this guy's turn to go to both, right? It's always first to both, second to both when you FOIL, right? So he's done. I took the 21 to both. Now it's the 4 root 15. Boom, boom. He's going to go to both. So first off, 4 times 21, 84 root 15. By the way, see how those cancel perfectly? That's why you do the opposite sign, because you want the roots to go away in the bottom, and see how that makes it happen perfectly? That's why you do the conjugate, which means opposite sign in the bottom. Meaning if they start you with plus, you use minus over here. If they'd started me with minus, I would use plus. You always use the opposite sign that's in the bottom. That way this happens and the roots go away. That's what we're trying to do, right? Get rid of the roots. Finally, 4 root 15 and 4 root positive times negative is negative. 4 times 4 is 16. And then root 15 again is plain 15. And so those will just multiply, right? Because they're both plain numbers. So we have that. What's 16 times 15? 240. Thank you. Negative. Yeah, and this one's negative also, huh? Negative 240. Okay, so let's bring it down a line. Let's see what we got. So we've got, so now we got minus 588. These two in the middle, they're like terms. Remember how the root rules work? You can add, yeah, when they have the same, it's like letters. It's like 112x and 63x, kind of like. That's why I always tell my algebra students, roots are like letters. So, it's like terms. It's like roots. You can just add the 112 and 63. was that 175?
Yeah, 175.
Root 15 minus, and then that was the 180 right there that came from 12 times 15.
The minus 180, can you combine that with?
Totally, yeah, and you could have done it right then. I'm just taking an extra step. Yeah, exactly. Kevin, that's exactly what we'll do. And then the bottom 441, these guys are gone. And then minus 240, we're so close. And now the minus 588 and the minus 180, I don't know what that is.
Negative 768.
Thank you. Negative 768? 768, whoops, I'm totally running out of room here. Let me get rid of some of this. So negative 768 plus 175 root 15 over, and what's that down there? 201. There it is. That's a messy one. That would take half your test. That took us half an hour.
Yeah.
All right, so